Okay, our today's topic will be determining Y-bus matrix. Okay, we will be finding out the Y-bus matrix. What is Y-bus matrix? Y-bus matrix is equal to admittance matrix. Okay, Y means admittance, right? Admittance. So Y-bus matrix means admittance matrix. So here, at first, let's find out what is nodal equation. A simple one-line diagram of the two-bus power system is shown in the following figure. Here, a simple one: generator, transformer, line, transformer, generator. So you have two bus here, bus number 1, bus number 2. And in the following figure, let the impedance in per unit of different equipment are given as follows. Here, the G1, Z means this is not admittance, this is impedance, right? Admittance is equal to Y, impedance is equal to Z. They are opposite to each other. That means Y is equal to 1 by Z, always remember, and Z is equal to 1 by Y, right? Admittance and impedance, these two words you will hear a lot of time. Okay? Y is equal to admittance, this one, admittance, double T, not one T. Okay. And Z is the impedance. Okay. Here the impedance is given in per unit. Obviously, the different equipment are as follows. So G1, this one has an impedance of RG1 and XG1 per unit. G2, RG2, XG2. GT1, that means this one, transformer 1, RT1, Z, XT1. ZT2 is equal to RT2, JXT2, and the line is this one is RL plus JXL per unit. Shunt admittance of the line. Remember, this part is a bit tricky to understand. This part is going to make you make a lot of problem for you. This term is going to make a lot of problem for you, but you have to understand what is this. Remember the what is that, equivalent circuit? Remember, let's go to the equivalent circuit. What is the equivalent circuit? Yeah, this one. Remember the equivalent circuit of the, okay, clear. Transmission line. What is the transmission line? Yeah, this one. This is the transmission line, right? Here, these are R and X. This one is R by 2 and X by 2. This one is R by 2, X by 2. What are these? These are actually this one. Okay? So when you have one R and one X, that is R, that is X. When you have 2R and 2X, this one will be divided by 2, this one will be divided by 2. That's it, a pretty simple thing. But what is shunt admittance? Shunt admittance is this one. Okay? If you use pi model means this model. If you use pi model, your shunt admittance will be half, right? Half, 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 half. And if you use T model, your shunt admittance will not be half, rather your actual admittance or impedance will be what? Impedance will be half. See this one. This part is impedance, right? This one is not impedance. This one is what? Admittance. Got my point? This one is what? Admittance. This part is impedance. This part is admittance. This one is admittance. That's why the symbol is different. This one is G by 2, not R. This one is G by 2, not R, right? This one is B by 2, susceptance, not X. This one is B by 2, susceptance, not X. X is reactance. Opposite of reactance is susceptance, that is B. R is resistance. Opposite of resistance is G. G is the conductance. And as a whole, they become admittance, Y. So remember, that is shunt admittance. Now if you use T model, the admittance will not be half, it will be equal. The whatever you have, you will write there. Okay, let's go there. This is GL plus JBC. That is a shunt admittance. Now if you draw the impedance diagram, that means detailed impedance diagram, this is your generator, resistance, reactance. That is your transformer. Transformer has one resistance, one what? Reactance. Here they didn't say the shunt admittance for your transformer, right? So you will write it like this. Then you have transmission line. Transmission line has one resistance, one reactance, and half admittance, half admittance, right? Shunt admittance, these are all. Then you have transformer 2, then you have generator 2. Now you know all the values here. Why? How? This one is this one, and this two. This one, are these two. This one is transformer 1, this one is this one, and these line are these two. And the shunt admittance, this one and this one, they will be half, GL by 2, GL by 2, BC by 2, BC by 2. Okay. Now simplified impedance diagram by adding the series combined impedance and draw the new impedance diagram. See this one here. This one is combined. Combined by how? You have two buses, right? One is after transformer, another one is before transformer. So here you have one bus, here you have one bus. So this part we can combine together. How? Resistance plus resistance, reactance plus reactance. This part we can combine together. Resistance, resistance, reactance, reactance. Okay. So this is the combination, series combination. So we combine together. Then what? We can draw the impedance diagram. Okay. We have drawn. Now the nodal equation, right? Nodal equation is how your current will flow. You will express that in a form of equation. So convert all the impedance into impedance diagram and voltage source into current source. Ig1 is equal to Eg1 divided by Zg1. You have a voltage here that is called Eg1. You have reactance and impedance, resistance, that means total impedance, that is Zg1. So what is the current that is flowing from here to here? Voltage divided by impedance, right? So Eg1 is the voltage, Zg1 is the impedance. So if you divide them, that is your Ig1. What is your Ig2? Again, same thing. Eg2 divided by Zg2. These are all formulas. These are not math. Remember, these are all formulas. Eg2 divided by Rg2 plus Jxg2. Okay. Now, what is your Zgt1? If you combine them together, here. If you combine them together, what is your Zgt1? Zgt1 will be what? Rg1, Rt1 plus J Xg1, Xt1. That means you are combining the generator resistance and reactance with transformer resistance and reactance. Total, you got Z generator transformer 1. Okay. Next one is ZGT2. So combining together. This will be necessary later. Now what is your, these are all your impedance. Now what is your admittance for this one? YJT1. See, these are all small y, capital, small y and capital L, they have two different meanings. I will explain later. One divided by that one, that is your admittance. This is your admittance for bus number 2. And this is your line admittance, line. 1 divided by ZLS, RLS plus JXLS. Okay, that is your admittance diagram. Admittance diagram means what? Admittance diagram, not impedance diagram. Admittance diagram, not reactance diagram. Remember, impedance diagram, reactance diagram, and admittance diagram, these are two different things. Admittance diagram means you will explain them as admittance, not impedance. That's why you can see previously this was voltage, right? This was voltage E, and you have resistance and impedance in series. Now you will convert that in a current source and parallel parallel admittance, right? So that is called admittance diagram, a different type of diagram. Now the nodal equation, we will learn that later, because the chapter name is Y bus matrix. We will cover the Y bus matrix. Let's do one math. Oh, before that, why Y bus matrix is necessary? Why Y bus matrix is necessary? You can ask. The Y bus matrix is necessary because the nodal equation that I was talking about here is this one. This is the nodal equation. Nodal equation means if you have multiple current, multiple voltage, multiple admittance, you can write like this. I1, I2 in a matrix form. See, I1, I2 is equal to Y11, Y21, Y12, Y22 into V1, V2. That means here, this one is the matrix for current, the value of currents. Okay? This one is the value of what? Value of voltage. And this one is what? The admittance. Okay? So this part we can call Y bus matrix. We can call Y bus matrix. Okay? Got my point? Okay. Let's see from here. Okay, I was going to teach this thing later. Okay, never mind. If you do that, your formula becomes like this. I1 is equal to Y11 V1, Y12 V2. I2 will be Y21 V1, Y22 V2. Okay, how I got this? How I got this? Let's go back here in the admittance diagram. What is the voltage here? That is bus number 1. The voltage here is V1. What is the voltage here? Bus number 2 is V2, right? Got my point? So I1 means what? Current of bus number 1 will be Y11 into what? V1. How I can write that? Normally the formula for current is what? Formula for current is V divided by Z, right? Now here, can we call it V into 1 by Z? 1 by Z is equal to what? Y, right? Can you call YV? So your current is equal to Y into V, right?
Yes.
So here you got the formula. I1 is equal to Y11 V1, Y12 V2. Why two terms? Duita term keno? Because we have two generators, right? One current can go in this way, another current can come in this way. So they will be added, right? So Y11, YV1, Y12, V2, Y21, V1, Y22, V2. So these are the formula for your currents, right? Now, if you write them in a form like this, that is also valid. How? Why they are valid? See, this is the matrix, right? This is the matrix, right? So if I tell you, okay, multiply these two matrices and write. So what will be your writing like this? Now let's multiply. See, y1, now I1 will be what? Y11 into V1 plus Y12 into V2, right? Next term, two-one into V1, 2-2 into V2, right? You can see this is a multiplication of the matrix, and these two equations are completely equal to previous equations. So these two equations are written in a form of matrix. So these matrix is called nodal equations. So at one side you will have I, in another side you will have a matrix of Y, a matrix of V. So I matrix equal to Y matrix into V matrix. So this Y matrix is called Y bus. That is the goal of this class, Y bus. So we will find out the Y bus. So here you can see the Y bus is capital Y11, capital Y12, capital Y21, capital Y22. That is the Y bus matrix. Let's find out the Y bus matrix from this example. How to do that? The one-line diagram is shown in the following figure of a simple two-bus power system. Line impedances are marked in per unit on a 100 MVA base, right? The line has a total shunt admittance. See, this is the line. Line has a total shunt admittance 0.4 plus j 0.8 per unit, shunt admittance. Determine the admittance matrix, that means the Y bus matrix. Y bus matrix for the following line diagram. So here, how many buses you have? You have two buses, this one and this one, right? So these are all your per unit value, right? Yes, these are all per unit value. So you do not have to convert them to per unit. Now let's draw the impedance diagram. So EG1, this one plus this one. What are these? What is this? This is the combination of the transformer and the generator, right? I told you these are a series. What is this? This is the combination of transformer and the generator. This one is your line. That means the 0.1 and j 0.05. And most importantly, this part is called your shunt admittance. Remember the shunt admittance? Since you are using pi model,
Yes, sir.
since you are using pi model, so this will be half, this will be half. So 0.2, 0.2, 0.4, j 0.4, j 0.4, right? Pretty simple. Now, these are self-explanatory. XGT1, no, ZGT1, ZGT2, YLP, that means the line shunt admittance 0.4, j 0.8. So your YLS is equal to ZLS. Your admittance for this one will be 1 divided by 0.1, j 0.5. This one. YGT1, that means the shunt admittance, will be 1 divided by this one. So you got these. So your shunt admittance will be these for your generator 1 and transformer 1. Your shunt admittance will be these for generator 2 and transformer 2. Your line admittance will be these for your transmission line. And you do not have to convert them by one by. Why? Because they are already in what? Already in what? Already in admittance. Remember this. Now you have to convert them. Now you have to make the what? The Y bus matrix. How? Y10. 10 means what? Bus number 1 to ground. Bus number 1 to ground. Bus number, which one is bus number 1? This is bus number 1. 0 means the ground. So how can you do that? 1 to 0. So which are the things that will be added? This one plus this one, right? Since they are parallel, so they will be added. Got my point?
Yes, sir.
So see this one. 0.28 minus j 0.06, 0.69, 0.4 by 2, that means 0.2 actually, 0.8 by 2, that means 0.4 actually. So you got 0.48 minus 0.29i, that is for your 10. That means small 10 is this one. Then you have to find out small y20. Small y20 means from here to the ground. So from this point to ground, how many admittances you have? One is this line, and another one is this line, right? So they will be added. So you got y20. Then you have to find out y21 and y12. Small y12, that means from 1 to 2. Which one you have? This one, right?
Yes, sir.
So your y12 will be 0.385 minus j 1.92, this one. And what about y21? Again, from 2 to
Same.
1, same. So these are the terms you have find out. These are all called self. These are all called admittance. Now you have to find out the self admittance, and you have to find out the mutual admittance. So maybe you are not understanding it very well, but when I do an example, you will see it is very easy. Okay, not very tough. Now y11, this is called self admittance. That means the admittance of bus 1, y11. Then you have y12. So let's go to the nodal equation again and see. Here, this part is called self admittance. This part is called self admittance. This part is called mutual admittance. This part is called mutual admittance. So how do you know which one is self, which one is mutual? Remember, when the numbers are equal, when the subscript number are equal, those are called self admittance. When the subscript number are not equal, that means y12, 21, 23, 24, those are all called mutual admittance. Understood? Self and mutual.
Yes,
So,
sir, understood.
okay, y11 will be,
Yes,
11 means what? 11 means bus number 1. What are the admittance that is connected to bus number 1? So y10, y12, right? So you have two admittance that are connected. Number 1 is this part, and this part. Why? Because they are all connected to bus number 1. So these plus this part is called y11, right? No, not 11. y10, right? Small y10. This part to this part is called
1, 2.
12. So your capital Y11 will be Y10 plus Y12, right? This is called self-admittance, remember. Now for bus number 2, at bus number 2, what are the admittance that are connected?
Y21.
Y20.
This one, that means this is called Y20, right?
20.
Plus
Yes, sir.
this one as well,
21.
right? Y21. Understood?
Yes, sir.
So this is your Y22. Now, what about your Y12? This one is also self-admittance. What is your Y12? That is your mutual admittance. Remember, mutual admittance is equal to, that means capital Y12 is equal to small y12, but with a what? With a negative sign.
Right.
Then y21 will be equal to small y21, but with a negative sign. Why? Because they are all mutual admittance. Mutual admittance will always be negative. That means opposite sign. Okay? Okay, everyone? So let's
Okay, sir.
okay,
Yes, sir. Understand.
let's find out y11 is equal to y10 plus y12. 11 formula value is 10 for value is 0.48 minus j. They have written I, you can write j, whatever you want, no problem. 0.29 j plus 12. What is 12? Here is 12. 0.385 minus j 1.92 we have written. So if you combine them together, this will be your answer. For y22 will be what? 0.48. This one, this one, this one. So if you add them, this is your answer. Y12 is equal to y21, because they are all same, equal to minus. See the minus? Can you see the minus? Can you see the minus?
Yes.
Because this is mutual. These are all self. These two are self. This one is mutual. So this will be opposite. So now you got all the components of your y bus. Y11, y12, y21, y22. Then your answer is complete. Y bus answer is complete. Understood? Now let's do a math that is difficult, that is big. Oh no, let's do these. Okay, let's do this. At first, let's do this. Here, so this is the end of today's class. I'm going to show you the problem. Then we will finish this class, and you can read by yourself what are these. Okay, you can read it. So once we do this, once we do this, you can do this by yourself. Okay, you can do it by yourself. So you will do it by yourself up to these self-study. Okay. Once we finish the assignment 1 solution, you will do it by yourself. Can you do that? Up to this, okay?
Yes, sir.
Up to page number 22,
Yes,
you will
sir,
do it by
will do.
yourself. Now here, consider the power system given in the figure. This is the power system in the figure. Here you have 4 buses. 1, 2, 3, 4. So it is fairly complicated for you. 4 buses. This is the one-line diagram. And find the y bus by manual calculation. So we will find y bus by manual calculation. That means the calculation we have seen in today's class. Okay. Then they have said, okay, use a general program for MATLAB by building y bus. So we are not going to focus on that. We are going to focus on manual calculation. Now here, all the impedance are given. Impedance, see. These are all impedance, not admittance. These are all what? These are all what?
Impedance.
Impedance, not admittance. What do you have to do? Not this one. What do you have to do? You have to convert them to admittance first. So let's draw the admittance diagram first. See how should I draw? How should I convert the impedance to admittance? Let's convert all the impedance to admittance. How? S3 per unit is this one. So here you have loads, right? You have loads. What are the loads? Here you have one load, that is S3. Here you have another load that is called S4. So you have to convert this load to the impedance first. How can you convert the load to impedance? I mean, how can you convert the load into admittance? Like this. S3 per unit will be what? 100 megawatt plus J 25 megavar, and what is that? The base is 100. So let's consider the base is 100. So 1 plus J 2.25. normally this is the value that will be given. Remember, this is the value that will be given here. This math was complicated, that's why this is not given. This value will be given. If I tell you to find out only the admittance diagram or Y-bus matrix, this value will be given. Since the value is not given, so that's why we have done that. So S, so 1 plus J 225, that is your S, not Z yet. So Z3 per unit will be VPU square plus S per unit 1.0 divided by 1 minus J25. Why? Because that is the conjugate. So you do not know what is this yet, not yet. So you do not have to worry about this, how we got that. So you do not have to worry because this, you do not know what is this actually yet. So this is your Z for 3. Z means impedance of this load. Impedance of this load is 0.941177 plus J 0.235294. That is your S3. What is your S4? Again the same formula, same thing. The S3 is this one. S4 is this one. Okay. So in the exam, in the problem, these will not be given. These will not be given. Rather, I will give you the I will give you the what? I will give you the impedance. So to make your work easier. Okay. Now let's convert all the things into admittance. The admittance diagram is shown below. Admittance. How can I convert the admittance? How can I convert the impedance to admittance?
1 by
1 by. So 1 by 0.25 is equal to minus J4. How do I know that? See,
4.
go to the complex. Number 2, 1 divided by 0.25i, right? Minus J4. So this is your 1 divided by. So you have to write with minus, remember. So this one J 0.4. So this one will be opposite. So J minus J 2.5. This one is 0.1. So this one will be minus J 10. This one will be J 0.2. This one will be minus J 5. Again, everything will be opposite, right? 1 divided by. So minus J 4 opposite these opposite. Now this one, you see, it is minus J 4. So it will be plus J 0.25. This one, S3, here, that means Z3. Your Z3 was this. No, your Z3 was this, right? Your Z3 was this. Here, your Z3 was this. So it will be opposite. Once it will be opposite, here there is a mistake. Admittance, right? This one should be Y. Admittance is a Y, right? This is the Y. So this one will be opposite. Once they are opposite, you got your admittance diagram here. Now you have to find out the Y-bus matrix, Y-bus. See, since you have 4 buses, so your Y-bus will be like this. Y11, Y12, Y13, Y14. Then this is your Y-bus matrix, right? Among them, this is self, 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 and self. Other those, all of them are what? Mutual, right? Okay. What is your self now? From here, can anyone find out what are the self?
Y11.
Okay, let's do it.
All Y11, sir.
See,
First will say 1,
Y11
So
will
first will
be
say 1, 0, 1, 4, 1, 2, and 1, 3.
exactly. So what is your Y10? 10 means what? What is your Y10? From 1 to 0. That means this one plus this one, right?
Yes, sir.
Yes, sir.
Plus Y12. What is 1, 2? This one is 1, 2.
Minus
Then Y13. What is 1, 3? This one is 1, 3, right?
Okay, plus 3, sir. Yes.
Then you have 1, 4. What is 1, 4? There is 1, 4. So
The middle one.
these are the things they will be added. What are the things added? This one will be added. These. If you add all 5, you will get Y11. Got my point? Now Y22. Again, this is your bus number 2. So you will have small Y20. 20 means what? This plus this. Then Y21. Which one is 21? This one is 21, right?
2, 4.
Then you have 23. See, you do not have any 23, right?
0.
If you do not have any 23, this will be 0. Okay?
Yes, sir.
So you can write 0 or you can ignore it. Your wish. Okay? This one is how much? It's 2, 4. Understood?
Yes, sir.
Okay. So this is your Y22. Y23 will be what? Y33 will be what? 30. 30 means this plus this. 31 is this one. 32 is 0. 34 is this one. So these 4 will be added. Y44 will be Y4040 will be this plus this. 41 is this. 42 is this. 43 is this. Understood?
Yes, sir.
These are all your what? These are all your
Yes, sir.
self-admittance. Self-admittance. So these are the values that are written here. These are all your self-admittance. What about your shunt admittance, mutual admittance? Mutual admittance means 1, 2, Y 1, 3, Y14. Then you have Y21, Y23, Y24. Remember, I have shown all the things. So 4 of them was self, other them were what? Mutual. 3, 1, 3, 2, 3, 4. See, Y12 will be what?
3, 4.
Minus Y, small y12, right? 1, 2 what? This one is the Y12. So since there is a minus, so this minus will be plus. So J4. Y13, 1, 2, 3. This one, right?
Yes, sir.
Minus Y13. How much? J10. 1, 4 is this one. Minus. Understood, everyone? What about
Yes, sir.
the Y21? 21 means again. See, this value and this value are same, right? These two values are same. So these are the things you have to calculate. So once you calculate these, you will see these are all your mutual admittance. See, all of them are plus because there is a minus in front of it, so they become plus. Y23, when you do not have any admittance, like from 2 to 3 and 3 to 2, so that will be 0. So you got all the values, then you put them in the Y bus matrix. That's it. Your work is done. Understood, everyone?
Yes, sir.
Yes, sir, understood,
Your
sir.
work is done. Now
Yes,
let's do one from here.
Sir, question. Sure, sir.
Yeah.
Sir, how about if it's become T model?
Oh, T model, for T model. Okay. If here in this example there is no pi model, T model, or shunt admittance that was not given. I told you before, if the shunt admittance for the line is not given, you do not have to think about that. Okay. In this case, there was no shunt admittance given, but here we had something called shunt admittance. Understood?
Yes, sir,
Here the
understood,
shunt
sir.
admittance was given, but here shunt admittance was not given. What it was given? Rather, it was given something like this. These are not mentioned, but these are given. Okay. If I do not ask about shunt admittance, you do not have to think. If here, come here and see. If your model is pi model, divide the shunt admittance by 2. If you think of going to T model, do not divide this, rather divide this by 2. Okay, rather divide this by
Yes, yes,
2.
sir.
But remember, normally we go for what? Okay, understood?
Yes, sir, understood, sir. Yes.
Okay, someone is speaking something over the mic. Okay, in my area, and they are making a lot of noises. Okay, now here, so you will go for pi model if that is not mentioned. Understood?
Yes, sir, understood, sir.
Okay, so we can do a math, or you can study by yourself. Then we will do the math in the next class. Okay, so your work will be study up to page number what?
22.
22. Especially you will do this math. That means example 2, problem number 2.1, problem number 2.2. So up to 22, page number 22, you will do it by yourself. Then we will try to go for MATLAB codes. Okay, we will go for
Yes, sir.